Hello, so I finished prototyping and building the retract system for my Kamov KA-50 110 scale. It's built around the JP retract system where I'm using the linear servos and the controller, which also has an integrated sequencer for the undercarriage doors, which will come in handy later on. So let's have a look. Open, as expected. And same for the set of mains. Nice. So now I've designed them and built them with the idea to have a mechanical lock whether they're in open and closed position. So you can see there's very little small tolerances here, but really it's a mechanical lock where the undercarriage is locked against the pinion, which is locked against the plate, and the plate on this side preventing the lateral motion. So I might correct the tolerances here a bit more to have it tightened. Same for this one, you can see there's very little slack, and it's locked between the pinion here, which is locked against the plate, and the plastic part here. And it's same in a closed position. Of course, in the closed position they're going to be hanging down, so you can see they're locked against the pinion, and if they would be upside down, locked against the plastic plate here, and the same situation on the front one. So this way I know that even if I have a failure of the servo of electrics, because it's not relying on the load on the servo, I will have a lock and the undercarriage will be safe. Now, front retracts by exactly 75 degrees, the back one's by 50.7 this is as a real design, so when it's installed, this will be installed on an angle, so the undercarriage folds into the fuselage, while when it's open, it faces forward. Now, parts have been printed in glass fiber ABS, and I already measured the main ones in an open position. They can withstand the load, each of them around 3.5-3.7 kilograms, which should be sufficient for a model which will be around 7 kilos, but leaves very little margin of error. As you can see now, under a load here with a strut, there's quite a lot of stress on those two parts and the hinges here, and they generally tend to fail. So what I will do is I will try to reprint this in nylon, in PA6 carbon fiber, in which in theory should be stronger. If I get it to around 4.5 kilos load limits, then I will be happy. If not, I will be looking at ordering those parts to be 3D printed in metal, in aluminium, using the DMLS technique, so direct metal laser sintering, because machining those would require 5-axis machine, and it will be prohibitively expensive. DMSL method is a bit more cost efficient, especially for this kind of low volume fabrication. Option 3 will be to have only the small parts machined. And looking at the design, this should be doable with a 3-axis CNC machine, so still reasonably doable cost-wise, while the strut could be fabricated, well, basically casted and made using carbon fiber, forged carbon fiber technique, but of course that would require making a set of molds for those small parts. So hopefully PA6 nylon with carbon fiber is the answer. If not, 3D printed metal, and we will see how it goes. In the meantime, of course, I will use those parts as prototypes to verify the fitting on the fuselage, and we will go from there. So hope you enjoy it.